Electricity is generated when electrons flow from a battery or any other source of energy. How does the energy from a battery flow into the bulb? Let's perform a simple activity to understand this. Connect the battery to the bulb using two pieces of insulated copper wire. What we saw now is the transformation of electrical energy into light energy. That is, the electrical charges flowed from the battery through the wires into the bulb along a set path called a circuit. Thus, electric circuit can be defined as the path along which the electric current flows. Facts about electric current. Electric current is the rate of flow of electric charges or electrons. Ammeter is used to measure the strength of electric current. SI unit of electric current is ampere A. Battery provides force or energy to drive the electrons. This force is called the electromotive force or the potential difference. Voltmeter is used to measure the potential difference. SI unit of potential difference is volt, V. Click on the links to know more about electric circuits. What makes circuits work? To make a bulb glow, a source of electricity or cell has to be included in the circuit. The source can be either power from the mains or cells. Displayed here are two circuits. Click on the circuit which you think would light the bulb when a battery is introduced. This shows that the bulb will glow only if the circuit is complete or closed, thus providing a path for electricity to flow. And the bulb does not glow if the circuit is incomplete or open. All these circuits are open and hence no current flows through the bulb. Perhaps as a child you noticed that the torch didn't glow when you changed the cells, but an adult easily set it glowing. What he did was to reverse the direction of one of the cells and the torch bulb glowed. This shows that the way in which the cells are arranged is important. If more than one cell is used in a circuit, remember to connect the cells in such a way that the positive terminal of one cell is connected to the negative terminal of the other cell. Let's see why the way in which the cells are arranged is important. When a cell is connected in a circuit, the electric current starts flowing. That is, the electrons continually flow from the negative terminal to the positive terminal of the cell. The same thing happens if two cells are included in the circuit. If the cells are facing in opposite directions, then the electrons go one against the other and the current does not flow. How do we turn the lights, televisions, electric fans and hair dryers on or off? These devices are turned on or off by just clicking a switch. What is a switch? A switch or a key is a device used to close or open an electric circuit. A simple switch is made of a metal lever that can join up with a metal contact. When you press the switch, the two pieces of metal touch and the current can flow through it. When you release it, the circuit is broken. The buttons on computer keyboards, mobile phones, remote control, and calculators are a type of switches and are commonly known as push keys. Switches on the television, hairdryer, and light bulb are known as toggle switches as they toggle between the on and off positions. When we perform experiments in laboratories, for convenience we use plug type key or switch. Here is a diagram of the plug type key. Electric symbols and circuit diagrams. Circuit diagram. Displayed here is a simple electric circuit containing a cell, switch, and bulb. It is tedious to reproduce such electric circuits. To save time and to avoid confusion, electric components like cell, switch, and bulb are generally represented with standard symbols like these. A diagram which shows how different components in a circuit have been connected using conventional symbols for the components is called a circuit diagram. Click on the Symbols button to view a few standard symbols.